Yes. Okay. So we will continue with a different example. Okay. So EE407. Today is November the 2nd, Monday. Okay. So our example is a slightly different one. It is a model of a float in a tank. Remember in 302, those of you who had started the term with me, we had kind of discussed in a funny way a mission critical control system, which was the toilet flush, which is essentially a mechanical control system. It just controls the level of the liquid in a tank, and that obviously requires, unless if you want to do something with very high performance, you need a model of how essentially something floats in a liquid. Okay. Now, what's happening is that we have basically a tank filled with liquid, and there is an object inside. So this is our liquid. Okay. And this object has mass m, and we apply a force F to this object, and also there is the effect of gravity. Okay, we also have gravity. Okay, so let me phrase this model. So we have a floating object. Floating object has a cylindrical shape with radius r, maybe I should put small r to radius r, and mass m. So that means we have basically a cross section of this object, right, with a radius r. Okay, and therefore a surface of it. So radius r. There is viscous friction. Yeni gelen arkadaşlar eğer hani bir kopukluk olup da geri gelmedilerse ders saatini kaçırmamanızı rica ediyorum. Olur mu? There is viscous friction between the object and the liquid, with coefficient K. And the liquid with coefficient K. This is essentially per unit area. That means the friction is also a function of the surface area that is in contact with the liquid. Okay, a downward force F is applied to the mass, This is essentially our input, and we are interested in how the object floats, and we are interested in how the object floats. What does that mean? That means we are interested in what's going to be the this x variable, okay? What's going to be the depth the object is buried in the liquid, okay? So our input is f, and our output is how does this variable x changes, okay? There is also the effect
Hocam yönü aşağı doğru değil mi?
of gravity. F'in yönü mü? X'in yönü mü?
Pardon, X'in yönü.
X'in yönü önemli değil. Çünkü temelde X bir magnitude. Yani suya ne kadar gömüldüğü. Ama sonuçta hani sudan dışarı çıkmayacağımız için X hep pozitif bir sayı olmuş oluyor. Yani X'in işareti yok. Hep artı. Sonuçta suyun dışına çıktığında ne olduğuyla ilgilenmiyoruz. Açık mı?
Teşekkürler hocam.
And also we have the assumption that the liquid level here, liquid level is constant. Okay? So there is no change in the liquid level. Okay. So is there any questions related with the model that we have just laid out? So you see the surface, at least the, sorry, yes.
Hocam yönle ilgili bir şey dediniz ya, hep aşağı doğru olacak dediniz.
Hı hı.
Tek yön olacak dediniz. Şeyi soracaktım ben, elektriksel sistemlerde KVL, KCL yaparken mesela KVL yaparken işte mesh current'lar tek yön hani.
Ama
Mekanik
orada
sistemlerde de böyle tek yön almak, mesela bütün kuvvetler sağa doğru olsun ya da bütün velocity'ler sağa doğru olsun gibi kabullerde bulunmak faydalı olur mu? Aynı şekilde.
Now, related with these variables, okay? Now you always need to assume a certain positive direction for many variables, okay? For example, for currents, for voltages, you need to assign a positive polarity. For currents, you need to assign a certain direction. But in many systems, those variables can actually take both positive and negative sign. So that means in reality, the direction of the actual current, for example, can be in the reverse direction of what you have assumed to be the positive direction. So making assumptions on the direction does not mean that those variables always, or those currents or voltages will always have the same sign. Okay? You make an assumption on the direction, and then you determine when that variable is positive and when it's negative, because often those variables are also time varying. So they will take positive values and they will take negative values. But in this particular example, because we are measuring how much this object is buried in the liquid, and we are not interested in the object coming out of the water, x is an always positive variable. So its absolute value is what's important for us. Does that make sense?
Diğer durumlarda en kötü negatif çıkar diyorsunuz hocam.
En kötü diye bir şey yok. Negatif çoğu zaman mutlaka çıkacaktır. Yani sonuçta mesela DC bir devrede bile eğer direction'ı farklı şekilde assign ettiyseniz bir quantity her zaman constant ve negatif çıkabilir.
Yani en kötü derken yönü ters seçtim diyelim.
Evet, ters seçebilirsiniz. Bir sıkıntı olmaz. O variable'ı negatif bulursunuz sadece.
Tamam hocam.
Eğer doğru çözdüyseniz. Ama çoğu zaman tabii ki ne diyelim, intuitive bir işaretleme, intuitive bir yön vermek Mesela atıyorum bir mass'in üzerindeki bütün kuvvetleri aynı yönde pozitif seçmek falan işleri kolaylaştırabilir, kafa karışıklığını önleyebilir. Yani doğru default direction'lar seçmek de faydalı olabilir problemi çözerken.
Teşekkürler hocam. Ya
Okay.
elektriksel sistemlerde alışığızdır. Mekanikte biraz kafa karışıyor, o yüzden sormuştum.
In mechanical systems, right, it's the biggest thing is the free body diagram. In the free body diagram, you have to assume directions for the forces, for example, the friction force, right? If you often what we do is that, for example, the frictional force is often in the reverse direction of the motion. Okay, and if you take that kind of a direction as your default direction, the frictional force will come out to be positive. Okay,
Tamam hocam. Teşekkür
but
ederim.
for example, the motion itself, the position and velocity will often change sign because they will not consider the angle variable that we defined in the pendulum system last week, right? Because the pendulum is actually having an oscillation motion, so the angle will always be positive and negative successively, right? So you will always have positive and negative sign. Okay, so let's take a look at how we're going to solve this. You see, this system is primarily a mechanical system because there is a mass, there is gravity, there is a force, and there is position. But it also requires some domain knowledge, right? You cannot solve this system without going ahead and researching how the objects float, okay? And so that requires some domain knowledge even beyond the mechanical systems knowledge, right? Do you guys remember what is governing floating objects? What law governs floating objects? Does any one of you remember at least the name?
Arşimet miydi?
Yes, that's correct, right? The Archimedes principle is basically determining how or what kind of force will the liquid exert on the mass if you bury the mass inside the liquid, okay? So we will both make use of our mechanical system knowledge. That means we will construct a free body diagram as in 302, but we will also integrate Archimedes' principle to determine the buoyancy force, the force that lifts the mass out of the liquid. Okay? So, free body diagram. So, let me write like this. This is primarily a mechanical system except for the presence of the buoyancy phenomena, which requires Archimedes' principle is needed. Okay, often in many systems you have primarily the system belongs to a certain category, so you apply your fundamental knowledge about that category, like the free body diagram here, and there is also one or more physical phenomena, extra phenomena that determines a force, determines a current, determines some variable in your system, and you need to also consider that. Okay, so the first thing we need to do is the free body diagram. Okay, so let's maybe change our color to something, I don't know. So this is our mass M. So we know that we are applying a downward force F. This is the external input. We also know that we have m times the gravitational acceleration as a downward force. We know that there will be some x variable, the buoyancy, how much this is buried inside the liquid. Arkadaşlar sesim geliyor mu?
Geliyor hocam.
Ha.
İyi gitti de hocam.
Çok yavaşladı da onun için. Biraz önce çizdim figürü bayağı. So we have also the frictional force. If the object is moving downwards, that means the velocity direction is downwards. You see, x might not have a sign, but x dot definitely would have a sign, right? So we need to assign still a direction, and the downward direction is the positive x and positive x dot direction. So we have the frictional force Fk, and we also have, Fk, what is the, okay, Fk is our frictional force, and Fl is the buoyancy force, okay, the two forces, the extra forces. So we will need to determine those. F and mg are obvious, but let's first calculate the frictional force Fk. Now, frictional force is between the object and the liquid, and the interesting thing in this example is that the friction really is determined by the area of contact between the object and the liquid, and that is a function of how much I am buried in the liquid. Okay, so this is going to be K times the contact area, okay, times the velocity, because this is declared to be a viscous friction. Okay, so what is the contact area of this object with the liquid? Is basically the surface area that is within the liquid, and that's going to be simply the circumference of the cylinder, so 2 pi r, and times the height that is buried in the liquid, and this is x, right? So, okay, so this part is the contact area.
Hocam taban alanına bağlı değil mi pi rakamı?
Taban alanıyla yüksekliği çarparsanız volümü bulursunuz. Taban çevresiyle yüksekliği çarparsanız.
Yok, ben hani hem yanal alan hem de taban alanı ikisi de contact area'dır diye düşündüm ama.
Ama şöyle, taban alanı doğru, orada bir karar verilebilir ama orası sıvıyla doğrudan kontak halinde olduğu için, yani sıvıyı aşağı ittiği için orayı almıyoruz. Sadece yanda sıvıyla friction yaşayan kısmı alıyoruz.
Tamam.
Ama bir not düşebiliriz buraya çünkü güzel bir soru. Note.
Yani bir durumda bu bilginin
Note.
bizde olması lazım.
Veya sizde yoksa bunu bir assumption olarak, eğer aklınıza geldiyse bunu bir assumption olarak state edebilirsiniz. Yani dersiniz ki tabanın sıvıyla sürtünme yaşamadığı varsayılmıştır dersiniz. Geçersiniz. Yani her zaman mantıklı bir assumption söylediğiniz takdirde onu dikkate aldığınız, onu düşündüğünüz anlamına gelir. Yeterlidir yani.
Hocam bir de orada oluşan kuvvetler hareket yönünde olmayacaktır muhtemelen.
Bir saniye. Bottom surface is excluded from friction. This is an assumption. Bir daha söyler misiniz?
Taban yönündeki kuvvetler hareket istikametinde değil hocam.
Oradaki kuvvetler mg ve f
Yani
bunu
hareketimize dik yönde oluşursa da o da negligible amount'tur muhtemelen.
hangi kuvvetlerden bahsediyorsunuz?
tabanda friction olursa demişti ya arkadaşımız.
Evet, yani zaten işte sebebi ne olursa olsun yani tartışabilirsiniz. Sonuçta başka bir ne bileyim fluid mühendisi bir arkadaş geldiği zaman diyecektir ki oradaki friction'ı ignore edemezsiniz. İşte orada başka etkiler var. Yani mesela hareket başladığı zaman mass'le birlikte hareket eden bir su kütlesi oluyor. Ona hani added mass deniyor. Mesela denizaltıları modellemekle uğraşıyorsanız denizaltı ilerlerken onunla birlikte çekilen suyun hareketini de onunla birlikte hareket eden bir mass olarak modelliyorsunuz örneğin. Yani dolayısıyla hani burada basit bir şekilde modellemeye çalışıyoruz. Tabii ki farklı daha karmaşık prosesler burada olabilir. Hatırlarsanız ilk derste bunları bayağı tartıştık. Yani modelin approximation seviyesi her zaman sizin yaptığınız assumption'larla ve argümanlarla ilgili bir şey. Okay? So that is one of the equations that we have for the frictional force Fk. Okay, so that's one thing that we have. Let's also write down Fl, which is the lifting or buoyancy force. This is determined by Archimedes' principle. So that states that the lifting force actually is related with how much volume is immersed in the liquid times the density of the liquid. Okay, so volume immersed, the density, and the gravitational acceleration. So the principle states that the force will be equivalent to the gravitational force exerted by how much liquid is actually displaced. Okay, so you know, verbally Archimedes' principle says buoyancy force force of an object is equal to the weight in newtons, obviously, of the fluid displaced by the object. So we have FL. FL is first the volume of the immersed object. So this is going to be PR squared times X. Okay? So this is the volume times the density of the liquid, 1 times G. Okay, so that's going to be the extra force that we have. So Newton's second law can be applied. So net force acting on the object, net force acting on the object has to be equal to the mass times its acceleration. So we have, let's add all the forces acting on the object in the direction of the motion x. Okay, so that's going to be m times, sorry, my m was small m, mg plus the external force F minus the two forces. So we will have pi r square g x minus 2 pi r right, 2 pi r k x dot, and that needs to be equal to m times x double dot. Okay, so essentially we have obtained a differential equation. Let me rewrite it from the beginning, right? We have m times d square x of t over dt plus 2 pi r k 2 pi r k x of t dx of t over dt pi r square, sorry, this r was supposed to be, let me correct this r over here, 2 pi r k x dx of t over dt, pi r square g x of t, and that needs to be equal to mg plus f of t. Okay, so that is our
Yön seçtik ama burada. Az önce seçmek önemli değil demiştiniz.
yön seçtik çünkü x'in işareti önemli değil dedik. Bunun sebebi x hiçbir zaman negatif olmadığı için söyledik bunu. X negatif olmuyor ama başka bir şey negatif oluyor. Dolayısıyla bir yöne her zaman ihtiyacımız var. Biraz önce söyledim ya, x dot işaret değiştirebilir. Yani bizim x için seçtiğimiz yön hem x için hem x dot için söz konusu olmuş oluyor. Evet, x hep pozitif ama x dot her zaman pozitif olmayabilir. Yani sonuçta sıvının içinde yukarı ve aşağı hareket edebilirsiniz. Dolayısıyla x dot pozitif ve negatif olabilir. Okay. So now think about this. So this is a second order differential equation. Can I obtain a Laplace transform of this equation? Can I get a transfer function?
No, we can't.
Can you state what is the reason for that?
Non-linear.
It has nonlinearity, right? This is a differential equation model. This product right here makes it quite difficult. There is another reason I can't obtain a transfer function here. Can you also state that? It is correct. It's a nonlinear differential equation. What else is a problem? Arkadaşlar beni duyabiliyor musunuz?
Hocam az
Az önce
önce kısa bir
sesiniz
kesinti
hocam.
oldu ama.
Okay. So there is another reason. Bu arada benim şeyim de gitti. Bir saniye. There is another reason that I can't obtain a transfer function. Can somebody tell me why is that?
Other than the nonlinearity?
Other than the nonlinearity.
The system has plus mg on the right hand side.
Yes, right. So the gravity makes it difficult because it appears as if you have two inputs to this system, right? One is a constant input and the other one is a variable input, right? F of t is our actual input, but there is also a constant input to the system, which is because of the gravity. So gravity also makes it difficult or makes it impossible to get get a transfer function representation. Okay?
Hocam,
Any
kısaca
questions?
tekrarlayabilir misiniz acaba?
Yes. English please.
Baştan sözü
Yes.
gelmesi de.
Ne oldu? Kesildi mi? Konuşma mı kesildi?
Laplace neden alamadığımızdan başlayarak bir kesinti oldu da pek anlaşılmadı oralar hocam.
Evet. Siz söyleyin bana neden Laplace transformuyla alıp transfer function elde edemiyoruz?
The system has non-linearity in it.
Biraz önce soruyu soran arkadaş mı cevap veriyor? Ondan rica ediyorum.
Hocam ben anlayamadım da o yüzden sormuştum.
Tamam, ben de yorum yapın diye, biraz düşünün diye söyledim. Yani transfer function representation alamıyoruz. Transfer function representation elde edemiyoruz. Arkadaşlarınız şunu söylediler. Sistem nonlinear dediler. Doğru.
Hocam, time domain'e bağlı değil ağırlık.
Şöyle yani sonuçta time domain'e bağlı olsa da bu sefer başka sıkıntımız var. Sistem 2 input'u bir output'u olan bir sistem o haline geliyor. O zaman tek bir transfer function değil, 2 transfer function'a ihtiyacımız var. Superposition kullanabilmemiz lazım ama sistem nonlinear olduğu için onu da yapamıyoruz. Doğru mu? Evet.
Hocam, is the nonlinearity due to x times the derivative of first derivative of x term?
Yes,
That
I think
causes
so.
nonlinearity, right?
Yes. The product of the derivative with the variable itself. All right. Any questions up so far? So that completes our example, this example. So I have another example for you. Let's take a look at the time. So it's a, I guess, let's have our very quick exercise at this point, and I'm going to continue with another example after that. Okay. And I will open up a different, or maybe not. Okay. So my next example will be even a more interesting example. This is from your from one of your books, this Leung 94 book. It is an ecological model. It's a very fun model to derive. Okay, so we will continue with this, but at this point, could you please move on to your Metaclass web page, and let me